Hello, Sandy.
Hello, how are you?
I'm very well. How are you?
Yeah, I'm good, thank you.
It's good to be here.
Hmm. I see you and I are on time.
Yeah, we are.
Well, good morning from here.
Morning.
Bye. Afternoon from Joburg.
Morning from Seattle.
Hello, everyone.
Morning, Justin.
Hi, Justice.
Hey, Colin, Josh. Hello, Matt. Greg,
Hello,
Michelle.
Justice.
Hello. So maybe just hello, Renew. Foley did send his apologies. He couldn't make today's session. I'm not sure who else is going to be coming, but it is on time, so I'm going to start and share from here. Okay, Technical Steering Committee. Today is the 9th of October. There is our antitrust policy notice. If you have any questions about this and you are within the Linux Foundation, you can contact a Linux attorney. If you are outside the Linux Foundation, hopefully you have an attorney of your own. On today's agenda, we are going to give a quick, just a recap. We had a session this week with the PACES and Cyberin teams based on the learnings out of the development work that they had done so far, a bit of sort of a retrospective. We had the PACES team had cataloged all of the feedback in the pull requests that they had submitted, in particular for the multi-tenancy work. And then out of that compiled a sort of an onboarding guide for their own development team. They then sent that through to us. The Cyberin team also did a review of that, and then we had a combined workshop earlier this week to review the list. It was actually quite useful. There's quite a few things out of that list that we would like to put back into our own contributors guide. The learnings overall were very valuable. It's always nice to get somebody's first experience or encounter with the system. Helps us identify gaps in our own internal documentation and processes as well. So we thought it was a really useful exercise. I'm going to just quickly put up like one of the outcomes of that as well. Maybe also for the TSC record, it would be a useful introduction or an overview of what our development workflow and process actually looks like. And then just a quick status update on Tazama 3.0. We are actively working towards that. There's a slide on that, and I would also like to demo some of the functionality that we had now recently delivered so that everybody can see the work that has been done. So moving on quickly here. So this is one of the outcomes of the developer process. So this was effectively how we had crystallized our workflow for the system, and also where a lot of our automation has been implemented. So end to end, if somebody is now working on any of our code, this is the process that we expect them to follow. And all throughout this process, there are also points and junctions where automated code reviews happen, where there is automated code screening, where we check the things like the linting and we execute our Husky processes and so on. So just as a sort of a quick walkthrough, one of the primary principles that we would like to enforce, or at least that everybody should be following, is that when you are working on the code in any way, that work should be informed by an issue that has also been created on GitHub. So you shouldn't be doing any work in the dark or in the blind. You should be working off an issue. even if that's an issue that you have created yourself, just so that everybody else knows what you're working on and the work itself is fully described. Or typically, as happens in our projects, you would have that work provided for you in a ticket or a user story, and then you would follow that ticket. You would not be able to complete your work or submit a pull request if you don't have a issue that you are then linked to, or you certainly shouldn't. So you'll then find the issue, look at the work that you need to be doing, almost like a sort of, this is your job card, and then you will clone down the development branch of the code. As we've already seen in the past, we have all of our release code lives in the main branch. The main branch is intended to be pristine, so we keep that branch protected. No write access is allowed to that branch. That branch is currently locked. So all of the work that we do is expected to happen then in the development branch. You will then, usefully for you, you need to create a new branch for the work that you're going to be doing. So all of that work should be couched in your own branch. If you don't do it at this point, you're certainly going to have to do it before you commit your code. You can't commit directly to the dev branch. You're going to have to commit to what we call a feature branch. You'll be making your changes, and there you need to conform to the Tazama definition of done, which has been published in our documentation repository as part of the contributor guide. You have to make sure that you have tested things. You have to make sure that you've completed the documentation updates that you need to do. You need to make sure that you have, at least for your own benefit, followed good coding practices as outlined in our contributors guide. And then you also need to do all of the unit testing. We expect unit test coverage of at least 95%, although most of the code that we had written so far has unit test coverage of 100%. And then you're going to do all of your dependencies. One of the big challenges that we've had at the moment is Dependabot is a never-ending game of whack-a-mole. I did a quick record of Dependabot alerts from about the 13th of September to the 23rd of September. This was just after we had cleared all of our Dependabot alerts for the release of Tazama 2.2.0. We had 427 new Dependabot alerts during that 10-day window, and that generated 340 new Dependabot PRs that somebody needs to go and clear. So what we are trying to do here as part of our process now as well is, if there are any Dependabot PRs in the repository that you are working on that impact only the minor or the patch version of your code that you are working on, you should be able to update those dependencies here as part of your work. We don't want people to do too big a Dependabot work here, because that should actually be work that is focused by itself. So if there is a dependency that has a major version, which is effectively a breaking change or expected breaking change, that should be work on its own. But a minor and a patch version should typically be safe, but we do want a developer to actually be able to look at the impact of the change on the code so that we can make sure that that is actually making a beneficial change. It is generally not good practice to blindly accept all of these Dependabot alerts. Somebody needs to at least hold its hand through the process, and this is the point where you would want to do that. And then you're going to just do a npm run clean, which makes sure that your environment or your repo is refreshed or baselined. And then you're going to install all of your packages and dependencies. You're going to run your own unit tests. So you're going to make sure that all of your unit tests pass. So 100% pass on at least 95% coverage. There is also here an opportunity, if you wanted to, you could manually trigger some of the linting tests that we do, and also you could manually trigger Husky here. That would give you a preview on any code quality issues that you are likely to encounter when you try and merge this code. So we generally think that it's a good idea if people run this here anyway and not just wait for the automated trigger to happen, because by the time the automated trigger happens, it sends them back all the way to the make your changes block here. So you could save yourself some time by just running it early and being proactive about running the code quality tests. And then if your package needs to be built so that it can be used inside other packages, So for example, we have a plug-in pattern in a number of our repositories already. All of the rule processors work on a plug-in basis. So you basically need to generate the plug-in upfront so that it can be plugged into a later component. So the rule processors work this way. All of the plugins for the relay services work this way. And then also the plugin for the authentication services also works this way. So you will have to compile that plugin into a package. And then here after that, we as product typically own the end-to-end integration testing, but if you wanted to be proactive here, you could also run integration testing with your new code module in its GitHub branch form. So you can then run, or you can compile this package on your local machine, and you can plug it into the end-to-end Tazama value chain that you deploy out of the full stack, and you can test that the rest of the system works around your container as well. Not a mandatory step, but could be a useful proactive step for you as a developer. We're going to be testing this as a product team anyway. When we test it and we find something wrong, we send it back with a bug. So if you want to avoid a bug report, it's typically a good idea to be proactive about your integration testing as well. And then here you are going to stage your code, and then you're ultimately going to commit your code. And there's some pre-commit checks that we then do. You push your code, that then puts your code into GitHub. And from there, you'll be able to open a pull request that comes with a whole lot of additional automation, your code integration, CI checks, everything, all of that kind of stuff happens. There is then a 3-tiered review process for every pull request. We do ask that internal teams or project teams actually has a lead that does a peer review on that PR. We asked for that typically because we didn't want to waste the external reviewer's time by catching minor issues that the internal reviewer or the team should have known better about. So the internal team lead also does their review, and then the external team also does a review. And in our case, that external team is Cybran that we have contracted for the maintenance and support for now for this year. So somebody from, in this case, Basis would have done the internal review. Then Cybran would have done the external review. And then finally, all of our repositories now contains a code owner file, which means that the people inside that code owner file, which is currently myself, Sandy, or Scott from the product team, we then have to do the final review to accept that code so that it can be merged. And then once the merge happens, there's a whole lot of automation that happens here. So a code that is merged will generate the GitHub containers from the dev branch as a release candidate, and we can then do our testing in the full stack out of Docker Hub, right? So the code owner review is essential. You cannot merge the code without a product team code owner final review on the PR as well. So that's our end-to-end workflow. Before I move to the next slide, any questions? Alrighty, thank you. Okay, and then Tazama 3.0. Multi-tenancy is complete. We're going to show you a little bit of a demo of how that works. And also we did a independent variable update as well. The independent variable update is a preparation for a AI and machine learning calibration or fine-tuning future for Tazama. We do have AI machine learning calibration on our roadmap. It is currently under development with the Paces team and is supposed to be delivered as part of the features development that they are doing for Comesa. So we will have a process that somebody can employ following machine learning and AI to fine-tune the system based on either if they have existing labeled data already, that would be nice, or as they are accumulating labeled data through investigations on top of Tazama alerts, at some point, they will have accumulated sufficient data to be able to do a calibration of the system. For that purpose, the independent variable itself is essential, and I'll show you a little bit about what that actually means in the context of the development that we did. The DB migration is now currently actively underway. All of these changes, the multi-tenancy was supposed to be complete so that the DB migration can follow that development and go on top of it. We did find the independent variable update was actually a quick and simple change to make that would directly go into the multi-tenancy update. So we decided to put that one, wedge it in between so that that created a dependency that we resolved for the PACES team so that they can continue their work on the AI modeling side. Okay, so quick demo, right? So I'm going to go here. So this is the Tazama full stack. So we refactored our start process a little bit here. So there's a menu here with a whole lot of options. So I can deploy let me actually stop everything first. So we added some utilities here, and I can stop and remove all of the current containers. There we go. It is working. Excellent. Okay, cool. Thank you. Come along, event sidecar. You're not that big a component. Right. Okay. So now that everything has been removed, I can deploy a multi-tenant capable version of Tazama over here. So multi-tenancy, the way that it would work is if you don't have the authentication services switched on in the system, which we don't recommend, but it is a useful way for us to test the system because you don't want to constantly have to log in and out of the system just if you want to be able to test something a little bit further downstream in your process. So authentication services can be disabled for testing purposes. When you disable authentication services here, the system will generate a default tenant and attach that to all of your transactions. So under no circumstances ever will any of the data inside Tazama's perimeter now not be tenant capable. It may just be a default tenant, which is fine, but it still has to be tagged by a tenant identifier of some kind. So what we are going to do here is we are going to turn the authentication on. I definitely want to turn it on. Thank you. And then we are going to deploy the system with the authentication running through Keycloak. So we had updated the default Keycloak specification on the system here with at least 2 starting tenants. And you can also see here that we have created separate relay services flows for each of these tenants. So out of the system now, if you are generating any alerts for tenant 1, they would follow tenant 1's route. And if you are generating any alerts for tenant 2, they would follow tenant 2's route. So there is completely separate data flows out of the other end of Tazama for the generation of alerts and interdictions. And I can show you quickly here. So when we are looking at Keycloak, I'll log on to my Keycloak here. Admin and password. Please change this if you are ever using the system in a production environment. So what we now have is there is a Tazama realm, which is deployed by default. And under the Tazama realm, you typically have a number of groups. So you have the Tazama Transaction Monitoring Service Group, and you have the Tazama Administration Service Group. So under the Tazama TMS group, we now have a tenant 1 and a tenant 2 that will inherit all of the permissions and authorities for the Tazama TMS. And we similarly have a tenant 1 and a tenant 2 that inherits all of the authorities of the administration group. And then in addition to that, you have users that you can set up here that would belong to the same group. So they would then belong to tenant 1 inside the administration group, and they would belong to tenant 1 inside the Tazama TMS group. So this user, when it is connected, will then only be able to access services that have been authorized for tenant 1 in both the Tazama TMS and then also in the administration service API. Right. And you can add, as we develop additional groups now, as we expand the system, there will be groups here for the Tazama TMS. There will be groups for the Tazama Rule Studio. There will be groups for the Tazama Connection Studio. All of those additional front ends will have their own sets of permissions and authorities. So for example, here we can look at the roles. this particular group is able to send pack 008, 002, pane 01, and 011 to the TMS API. So you will then have all of the new groups will be added here, and then you will have the users defined, and you will have full tenant-based separation all the way down across all of Tazama's component services. All right. Let me go back here. I want... Okay, all of our containers are up and running. Let's go to Postman. So we've also refactored all of our tests, specifically to be able to test this functionality. We now have a test that interacts with the system as tenant user 1, and we have a test here that interacts with the system as tenant user 2. We would probably at some point want to extend this functionality to also include the demo UI, but the demo UI itself is an unauthenticated component at the moment, being a demo UI, so you don't have to log into it to be able to use it. But it would be useful, I think, to be able to fully illustrate multi-tenant separation, starting with the demo UI as well. So we may enhance the demo UI with that functionality. So let's look at this then. So I'm going to create my message in memory, which is just going to prepare to send it. And then I'm going to try and send my message to, and you can see unauthorized is the response, and the error that we are getting is unauthorized. I tested this earlier to make sure, which is why there's a lingering hangover, and I'm sending that through. So at the moment, because there is authentication in place, I am unable to submit my transactions to the TMS API now for evaluation. I'm not authorized to submit that transaction. So the first thing I'm going to do is I'm now going to use my access credentials to fetch my token. And let's send that through to Keycloak, and Keycloak will then give me a token that I can use. And we can have a look at what is inside this token. So if we go here, no, I'm in the wrong system now. Oh, wait, no, I'm not. Hang on. I am wanting to be there. Okay. So this is the token that we got from Tazama, and this is, we call this our Tazama token. And then inside this token, you can see all of the claims. So there's a token string that handles sort of the encrypted certificate. And then here you see all of the claims. So this particular user has the ability to manage accounts, has the ability to post transactions to the TMS API. It's got some access to the admin service API as well. So all of these are returned by Keycloak as claims. But here you can see, very importantly, that this user has been identified as a user of tenant 1, which means now that when the system, when this user interacts with the TMS API, all of their interactions will be tagged with a tenant 1 perspective. So let's go back to Postman here, and we are going to take this authorization token, and we are now going to wrap our transaction in that token, and we're going to send it through to the system again. So here we have a transaction that was received by the system. It's valid. And then here, we send that one through again. Also, there goes your pack 002. So what will happen now is we do have a control in place. So you will see that the transaction that we are sending is just the normal payload. I can show you, I think I may have that console turned off, so I can't actually show you. But you are not allowed to send the TMS API a tenant ID. Right? You're not allowed to do that because we don't want you to be able to impersonate another tenant if you knew what the tenant's code was. So the TMS API does not allow the submission of the tenant ID. The tenant ID is automatically attached to the record on the inside of the TMS API once you have been properly authenticated at the API. So what will then happen is I will now retrieve the transaction from the database to get the outcome of that evaluation. And you can see here, this is the transaction that we submitted, all of the additional information, and here's the report. As part of the transaction now, the transaction itself has a tenant ID that has been attached, and this tenant ID matches the tenant ID of the user that submitted the transaction for evaluation. This is automated by the system to make sure that we don't have some sort of man-in-the-middle incident here. And then the rest of the report itself there's a tenant-specific network map that was used. So somewhere here, there you see the tenant ID for the rule result. There's the tenant ID for the topology that was used, and the network map itself is also tenant-specific. Although I don't see that it has been tagged here. Sandy, please make a note so that we can double check that, but the tenant ID should also be part of the overall transaction result. All right. And now, so we now have a transaction that had been evaluated by tenant 1. We now also can create a second transaction for tenant 2. And again, following the same process, if we are trying to send that through to the system, this would not be allowed. Let's get our access token for Keycloak, and let's use that Keycloak token to get a Tazama token for accessing the system. Let's just double check this as well. And now you will see tenant 2, right? So once that second tenant user has logged into the system, into Keycloak, that user is now allocated a different identifier for the tenant. So when this user then interacts with the system, you will now get a result from the system that is linked to the second tenant. So here, there we go. The transaction itself is tagged with the tenant ID, and the full report will then also be tagged by the tenant ID. Ah, there we go. Thankfully, the network map also has a tenant ID. It's just not in the report for some reason, so we may actually want to fix that. And then this result is then linked to the specific tenant. So if we look at, for example, so this is ArangoDB on the database. We can look at the configuration setup here. You will now see that when you have your network routing set up, you actually have an active. No, that's wrong. I'm on the wrong thing. Oh, that's why. It'll help if I had the right IP address. Okay. You'll now see that there are 2 network configurations. Both of them are active. And the one is for tenant 1 and the other one is for tenant 2. So each tenant has their own network map. They can run their own configurations on the system in parallel to another tenant, but they can still share resources. So both of these tenants can use the same rule processor, but they are able to supply their own configurations. So even though they have access to the same rule processor in the system to minimize the proliferation of hardware, this one is for rule 901 for tenant 1, and this one is rule 901 for tenant 2. All right. Thank you. And then maybe just a note here. So for condition management, didn't mention this, but we typically have a public rule 901 that we have used for demo purposes. We've also now had to develop a rule 902 so that we can properly test and showcase condition management in the system. So that one is number of incoming transactions for the creditor. We needed rules that could handle both perspectives of a transaction, both the debtor and the creditor. That's not in here, but it is available in the system elsewhere. All right. Any questions on multi-tenancy?
Yeah, from my end, excuse the little, if any, knowledge around around technical matters. But looking at multi-tenancy from the little bit that I know, the architecture here for our solution, is this segregated in terms of databases where you have database per tenant or?
No, so unfortunately not.
Yeah, I was just going to say you should explain the row level access.
Yeah, so we are going to be implementing row level access control as well, which is a additional measure of control. But the idea behind this implementation is still to be able to use shared resources. We don't necessarily want to deploy multiple instances of the database because the database is almost the part of the system that has the consumes the most resources by itself. So if we can leverage shared resources for that purpose, then we may have better economies of scale for multi-tenancy implementations, and which may be better for financial inclusion. But you could still, if you really had to, segregate down to the database layer. When we are looking at that level of segregation, we would almost tell people to just deploy a separate instance of Tazama. Tazama does not require license fees to run and operate anyway. None of its components require license fees. So you might as well just, if you want that level of separation, deploy a completely separate instance of Tazama in your environment. And you can then run multiple separate instances of Tazama in parallel. Obviously, you lose the capability to leverage shared infrastructure, but
Yes.
If somebody has that strict a requirement for separation, then deploy a separate instance of Tazama. That's the only way really to ensure PCI DSS and ISO 27001 compliance. That, especially in the EU does not necessarily, as far as I understand, feel like mere separation of data logically is good enough. They require physical separation of data, which is not what we are aiming for here. We are aiming for lower cost operation. So shared resources, shared services, lower cost operation. To Greg's point is because we are now also going to be migrating to Postgres, we actually now have access to functionality that is typically paywalled in freemium kinds of solutions like the one that we are currently using with Harango. We will have access to encryption at rest, which will be part of the system natively, which will allow us to add better security to the system. But what we also get is record level authentication or authorization, which means that the database itself determines whether or not you have the authority to access a data record. There's no logical partitioning of the system anymore. You actually have to tell the database who you are, and then the database will decide whether or not you can see the data based on your role and your access to the system. So that is something that we will also be adding as an added benefit to the database migration itself, which will then bring us a little bit closer to providing a more secure experience for our customers. But thanks, Colin. That was a good question. Okay. Any other questions? Multi-tenancy? The demo for independent variable is a, how to put it, a lot less spectacular. I can show you how that looks here. So every rule result that we deliver from the system now has an additional attribute that tells you what the value was that we used to look up the rules risk classification, right? So let me explain that here by looking at our configuration again. So typically when we do our rule translation, so the rule result used to only be a category, right? So we would deliver this sub-rule reference here. But to deliver a specific sub-rule reference, we would send the rule processor a routine, a value that says we went and we did our behavioral analysis based on the rules programming, And we determined that in this case, for example, the number of outgoing transactions from the debtor was 2. And we send in the 2 to the routine, and the 2 comes back and says a 2 is class 1. Or here, a 3 is class 2, or a 3 or greater is class 3. I messed that up a little bit. 1, 2, 3. Okay. So in a case like this, where your bands are close together and fairly contiguous, it actually, you have the same level of granularity. So the translation between the value and the band is almost direct. But in instances where, for example, these bands are starting to spread out a little bit. So let's say, for example, it is, in this case, up to 5 transactions, then it's 5 to 8 transactions, and now it is 8 or greater transactions, for example, right? Now, there's a whole lot of values that all collapse into band 1, right? 1, 2, 3, and 4 are all mapped to 1. 5, 6, and 7 are all mapped to 2, and 8 or greater are all mapped to 3. So it's very difficult for you to now, once you only have this value, to unwind it to get to the original source value. And when you are doing AI and machine learning calibration, you don't want the band. You want the source value. And it's the source value that is going to be important, because there may be slight differences between 1, 2, 3, and 4 and the impact that it has on the model coefficients to be able to accurately determine if this is a fraudulent transaction or not. So the change that we have made here is to expose that source value in its entirety.
Oh, thanks,
So
Justin. I was about to ask that question. How does when we implement AI, how does it actually know the source piece?
Yes, so we wanted to be more transparent about it. So we are now outputting that source piece as part of the overall result. So at the moment, because we just did a single transaction here, you only see 1 here. But let's say, for example, no, I haven't actually got it set up like that. But if I keep on sending out more transactions, this independent variable will also accumulate based on the rule result. 2 transactions will give me a 1, a 2, a 3, a 4, so on, right? This is the FROP, by the way. Here we go. So this is the first transaction tracked by rule 901. If I send through another one from the same debtor, this will be a 2 and a 3 and a 4 and so on, right? So this information is a lot more useful in AI and machine learning modeling, and will also allow us to calibrate the rule processors directly for any of its other variables. So at the moment, rule processor calibration is very difficult. We would have had to almost try and figure out what these categories should be. In the long run, these categories probably won't matter anymore. We can entirely remove them. So one of the reasons we had these categories in the first place is because when we originally built the system, we had the anticipation of manual fine-tuning, report-based, data analytics-based fine-tuning. So having people only use 3 categories was a lot simpler than the entire range of contiguous values. But now that we are able to do this in a machine learning or an automated fashion, we can actually rely on the raw values instead. We need them, and we can now also just skip the categories already and go straight to the source. Josh.
Yeah, question. Can that be used as a guardrail by any chance for the AI, just as we do the hybrid layer method, or is that controlled by another mechanism?
So which part would you like to use as a guardrail?
Like, say, if the band or the subrule reference, could those be used as a guardrail for in case if an issue that came up?
I've been thinking about how we could still maybe keep them useful, purely because I have a bias towards sunk cost. But and the way that I might actually then do that is this risk classification here could actually then map to something that is literally a low, medium, or high risk, right?
Okay.
So
it has
for
a threshold
reporting
value.
purpose, it can have some sort of threshold value here. So once we have done our calibration, we can actually go back and recalibrate the what do you call it, the classification itself, so that you can directly use that for reporting purposes to say that this rule indicated a high risk class for this particular transaction. It may give you sort of like a quick shortcut to an evaluation. And then when an investigator also looks at this, they can see that the value is 5, but they can also understand that 5 means medium. Or they can see the value is 8 and 8 means very bad, for example. So I think there's maybe still a way that we can get some use out of that.
Thank you. I appreciate you explaining that too.
Cool. Thanks, Josh. All righty. And that's everything that we had today. A little bit more of a show and tell. Any other questions, any comments, concerns, questions about the future, questions about the past? Oh, in that case, I am going to call it there. Thank you very much, everybody. I'm very excited. Hopefully, if everything goes well, and I don't want to put a jinx on it, but in 2 weeks' time, if we have our next technical steering committee, hopefully we will also be able to showcase the new database. Fingers crossed. All right.
Okay, thank
Good
you.
luck, everyone.
Thank
Have
you.
a great day. And see you all
Thanks,
again in 2
Chad.
weeks.
You too. Talk to you in about 5 minutes, probably.
Bye-bye.
everybody.
Yes.